Across this interesting research work from University of Berkeley. So these researchers have come up with an idea of providing a memory to a large language model. So what is the key idea over here? The key idea is that a fixed context LLM processor, your large language models have fixed contexts. Okay. So it could be 4K, 2K, 8K tokens, 32K tokens, or 100K tokens, but it is fixed context. Okay. So how can you actually augment this LLM with something called as a tiered memory system and a set of functions, okay, which allows this LLM to manage its own memory? That is the key idea of MemGPT. Okay. So here they have something called as main context and external context, which together constitutes your virtual context. Okay. So what is main context? Main context is your fixed length LLM input. Okay. Now what is your virtual context? Right. So what happens is that MemGPT parses the LLM outputs, okay, at each processing cycle, okay, and either yields control to a function call which can be used to move data between the main context and external context. So when the LLM generates a function call, it can request immediate return of execution, okay, to chain together functions. In case of a yield, LLM will not be run again until the next external event trigger. Okay. So to understand more about these concepts, let us look at their paper. Okay. So this is a work from University of Berkeley, researchers from University of Berkeley. Okay. So the idea, as I said over here, is to provide an illusion of infinite context while continue to use fixed context models. Okay, so all your LLMs currently have a fixed context. Okay, anything out of the context, it will not be able to process it, right? So one way is to increase context, but if you have to increase the context length of transformers, then there is complexity in computational time and memory cost due to the transformers architecture or self-attention mechanism. Even though there are some newer papers which are coming about, which are talking about efficient architectures for long context, okay, but still there is some computational complexity and memory cost increase, okay, right, computation time increase, right? So what these researchers have come up is that memgpt is an OS inspired LLM system for virtual context management. Okay, so the idea is to provide a virtual context, right? So your traditional operating system has something has hierarchical memory management. What it does is that it effectively pages in, right, and out information. So you have fixed RAM, right? In your computer you have fixed RAM, which could be 8 GB, 16 GB, but then there would be an application which might use say 24 GB of memory. So what happens at that point of time is that your OS manages the memory. To the application it says that okay, you have 24 GB of memory, but it manages by paging in and out data from your secondary storage, which is your hard disk, to main memory as required. Okay, so the same idea they are trying over here by introducing something called as an virtual context. Okay, so the LLM processor over here in this architecture, okay, takes main context, which is analog to your OS or main memory, main memory or RAM. Okay, OS main memory RAM as input, and outputs text interpreted by a parser, resulting in either a yield or a function call. Right, memgpt uses these function to move data between main context and an external context. This external context is analogous to your OS disk memory. Okay, so when the processor generates a function call over here, it can request control to chain together functions before yielding back control to the LLM processor or before the next external event. Okay, that is the key idea over here. Now let's go into a little bit of details. right? Just to get an understanding. So there are two kinds of memory types over here in MemGPT, right? One is main context and other one is external context. Okay. Now, if you look into what is main context, right? In typical LLM based conversational agents, your significant portion of main context tokens is to hold a system message. Every LLM input which you give to an LLM will have something called as a system message or pre-prompt. Okay, it indicates the nature of interaction of the system. Right, the pre-prompts are nothing like you are a helpful assistant, you can do these kind of tasks, things like that. Right, and what they say is that this itself could comprise of a few tokens, or it could be very detailed in things which could have up to 1,000 tokens. Okay, right. And it is common for this pre-prompt to consume more than 1,000 tokens. That is what they are saying over here. Okay. Now, when you have this 1,000 token pre-prompt, okay, which they used in this MemGT experiments, what happens is that uh, as part of your prompt, you have this as part of your prompt to an LLM input. Basically, you have the system prompt, and then you have your task, right? So when you have conversations going back and forward between the LLM, what happens is that only it can support up to say only 60 remaining messages. That is what they are saying over here. If you just take the example of GPT-4, 32k tokens, right? The context window of 32k tokens, still it can support only up to 600 total messages back and forth. Okay, when a conversation is happening, because every time as part of your conversation what is happening is that this pre-prompt will be present. Okay, so it itself occupies some tokens, and it will only allow up to say 60 remaining messages when you are using 4K context models. Okay, what happens is that the previous message also gets attached to your prompt, right? And the previous response also gets attached as part of the prompt when you are having conversations. So in that way, just because of this token pre-prompt limitation, you cannot have more messages being sent. Okay, so that is what they are saying over here in this particular table. So what they are saying is that their main context is divided into three components. One is system instructions, which hold the base LLM instruction, right, which has information describing MemGPT functions and control flow to the LLM. Conversational context, which holds the first in first out queue of recent event history, messages between the agent and user, and something called as working context, which serves as a working memory scratch pad for the agent. Okay, so the system instructions are read only, so it will always be present to the main context. They do not change during the lifetime of the MemGPT agent. Okay, conversational context is read only, and it is based on a special eviction policy. If the queue reaches a certain size, a portion is truncated and it is pushed to your external memory. Okay, that's the idea over here. In that way, you can actually maintain the input context size over here. That is the key idea. Okay, and the working context can change, right, based on your task. Okay, that is the idea over here, right? So then you have external context, right? So if you look at this diagram, now we talked about what is this main context. Now we are talking about external context. So this is fixed number of tokens. External contexts provide you with this illusion of infinite tokens. Okay, right? So in this way, they provide infinite context to LLM. Okay, now let us look at external context. So external context refers to out of context storage that lies outside the context window of LLM processor, analogous to your disk storage. So here the idea is that information in external context is not directly visible to the LLM processor, but it can be brought into main context through appropriate function calls. Just like how your as OS in your computer manages memory, here that is the idea, right? So here they have two types of external context. One is called recall storage, okay, which stores the entire history of events processed by the LLM processor, right? In essence, the uncompressed queue from the active memory. And archival storage. Archival storage is which serves as a general read-write data store that the agent can utilize as overflow for in-context read-write core memory. Okay. So in the context of conversational agent, archival storage allows MemGPT to store facts, experience, preferences about the agent or user. Okay, beyond the token limit of main context and search over recall storage. Okay, that is what is this archival storage, where you can store facts, experience, preferences about the user or the agent, right? And the recall storage allows MemGPT to find past interactions related to a particular query or within a specific time period. Okay, so in the context of document analysis, archival storage can be used to search over an expansive document database. So there are two types of external storage, basically recall and archival. Archival stores, basically in kind your preferences, right? Facts, preferences, experience. Recall is kind of it stores your conversations and other things, right? That is the idea over here. Okay. Now you got this storage, right? You understood what is this storage, what is this main context, external context. Now, how does this control happen over here, right? So that is where you have this self-editing or self-directed editing and retrieval. Okay, so MemGPT orchestrates data movement between the main context and external context via function calls that are generated by the LLM processor. Okay, so the memory edits and retrieval are entirely self-directed. So this is completely an autonomous system. MemGPT autonomously updates and searches through its own memory based on the current context. So how did they do this? They implemented self-directed editing and retrieval by providing explicit instructions within the pre-prompt that guide the system on how to interact with its memory system. So that is part of the pre-prompt. These instructions are comprised of two main components. One is a detailed description of the memory hierarchy and their respective utilities. Two is the function schema, which describes about with their natural language description, which provides all the system calls to access or modify its memory. That is the idea. So what happens is that this LLM pre-prompt has enough instructions on how to actually make use of these functions and what are the memory and what are their functions. So the LLM processor is then able to decide on autonomously on, should I call some function to pull in some external memory, or should I how do I access this external memory? Should I do some function calls, and other things are present over here in the pre-prompt. That is the idea. Okay, right? So now we have covered that part also. So for example, they have an example over here. Here is a conversation. Okay, so what happens is that hello Chad. Okay, so this is I am excited to embark on this journey as a PhD student. Okay, so this is MemGPT, right? So here the user says, I took the day off. My mom baked me a birthday cake. It was my favorite, chocolate lava. Here you have this date. So it goes and appends, okay, this information that birthday 11th October is the birthday of his mom. So chocolate lava was made by his mom on that particular day. So this it kind of builds into its memory, right? Right, and it makes actually a working context append function over here, a function call, right? And then it gives a response. Okay, right? So then if you go down now over here, here what happens is that there is this conversation where the system says that the system gives out a warning that the conversation history will soon reach its maximum length. Okay, then MemGPT actually adds some more facts into its, after receiving this memory pressure from internal this thing, it writes details from conversation to external memory. Okay, because your conversation history is now going to reach its maximum length, right? So that is an example over here. Okay, right, then we'll go back to our this thing, the third and last part about control flow and function chaining. Okay, so how does control flow happen in this entire system? Basically it happens is that events trigger LLM inference. Events are generalized inputs to MemGPT and consists of user messages, system messages, user interaction. Okay, so here user messages in chat application, the user can send a message to the system, right? System messages are main context capacity warnings and other things. Okay, just like we saw this memory warning over here, which is coming from the system itself, right? And then you can have, okay, beyond this you can also have something like alerts. right? User interaction alerts. For example, an alert that a user just logged in, an alert that they finished uploading a document. It could be timing events that run on a regular schedule. Okay, so which can allow MemGPT to run unprompted without user intervention. So MemGPT processes events with a parser, converts them into a plain text message that can be appended to main context and eventually fed as input to the LLM processor, right? And many practical tasks will require you to actually chain a lot of functions. Okay, so what can happen is that you can have a task like computing something or retrieving some information or processing a document where you need to chain function calls, right, to get the outputs. So there what happens is that if you go over here, they've explained it over here. So there what happens is that in MemGPT you can have function chaining. Functions can be called with a special flag that requests control be immediately returned to the processor after the requested function completes execution. Okay, if this flag is present, MemGPT will add the function output to the main context. If this flag is not present, MemGPT will not run the LLM processor until the next external event trigger. So in this way, what can happen is that for a certain task, it can produce an output and control can be given back. It will get attached to main context and LLM will produce an output, and this chain can happen. Or this thing can yield, it can wait for an external event from the user. Okay, so that is the idea over here of control flow, right? So they have an example over here. This is about main memory, this thing. Okay, so here is an example about how MemGPT corrects information about the user by writing to main context. Okay, so welcome back. So this is after a particular event. It says welcome back to the user, and the user says that I don't like horror movies. I like romantic comedy. Then it goes and replaces the context that okay, I watch horror movies. I like romantic comedies. Okay, he doesn't. The person doesn't like horror movies, but they watch it. Okay, and then it updates this fact in its memory. Okay, so that's an example which they have shown over here, right? So these were about concepts of MemGPT. So what did they try MemGPT for? They tried MemGPT to make use it as a conversational agent. Okay, and they checked it for it on say deep memory retrieval task for consistency. So they have results over here. So how it performs. So what they say is that MemGPT performs much better than GPT-4 in this deep memory retrieval performance. Okay, where the agent is asked a specific question about a topic discussed in a prior conversation. Okay, which could be in sessions 1 to 5. Multi-session data, right? And is it able to actually retrieve that data and give it? Okay, so over here, if you see, MemGPT performs much better than any of the other things like GPT-4 or GPT 3.5. Okay, if you look at the performance difference, right? Then they tried it on as a conversation opener task. So basically, it has enough details of a person. So when you are next logging into the system, how does it engage the user? Okay, that is the idea over here. So here also says that they say that compare it to a human baseline of how a conversation is opened. It performs quite close to that. Okay, MemGPT with working context only performs close to that. That is what they are saying over here. Okay. Then, so for example, they have an example over here. So, this is about a user who says that I am studying the LSAT. I want to be an attorney. I used to live in New Mexico. This is a prior conversation or a prior personality of the user. Now, the gold opener or human baseline conversation opener is what date is this test scheduled? Okay. So now MemGPT says working context plus recall storage says that just brewing up a fresh pot of tea because I love tea on my end. How is your coffee? Okay, because this person likes coffee. Ready to burn the midnight oil with some study for this test. Okay, this is working context plus recall storage because it has stored these I love coffee, I love tea, and other things, right? This is working context only. Here it says, great to have you back. It's time for a fresh cup of coffee. As a tour guide, I meet so many people whom a good guru helps keep them focused. How is your study going? Right? And this is recall storage. So here it misses out. So this is an example of how MemGPT engages in a conversation opener. Okay. Then they have tried MemGPT for document analysis and question answering, multi-document question answering, and so on. I wouldn't talk about this. Probably you can look at the paper. Okay. So this idea is quite interesting, but there are some limitations currently for this idea to work, right? What they are saying is that they have made use of OpenAI GPT-4 because these models are fine-tuned specifically for function calling, right? They are not able to use other models like Llama to 7 billion parameter as the LLM. Okay, they are using OpenAI GPT-4 as the LLM because the other models like GPT 3.5 or Llama to 70 billion models are not good at function calling. Okay, which is very important for MemGPT's performance. Okay, so this is one limitation. And what they are saying is that in conclusion, this is an idea of providing the illusion of larger context resources for LLM. That is the idea. This is an OS inspired approach, and using this approach, MemGPT could process lengthy text well beyond the context limit of current LLMs. Okay, by effectively paging relevant context in and out of memory, right? So with this idea of providing hierarchical memory management in interrupts, your LLM can behave like an OS, right? You are bringing OS architectural context over here. So this is the idea of providing kind of memory to LLMs to exceed its fundamental limits. That is the idea over here. Okay. So they also have a GitHub page where you can find further details and you can try out the code as well, except that you need OpenAI access to GPT-4, right? And it might be expensive also because the OS makes calls to OpenAI over here, OpenAI LLM. Okay. So you can also try it out. I hope you like this interesting concept and this video where I'm explaining about MemGPT. If you like the video, please like, share, subscribe to the channel. See you in another video.